Good evening, everyone. I hope we are all doing good. I think we can start from here, and every other person can join as we go. So, good evening once again to another lightning session. These are our weekly meets where we learn new things or get deeper understanding of some very important concepts in the Spring Boot ecosystem as well as Java ecosystem, and also some insights into preparedness for interviews, connection, and etc. Yes, like our last lightning session, we dealt with a very important topic, which is questions that are beyond what is required of you from interviews. You get, which is a very important thing, and I believe we learned a lot. We've dropped that particular material for our revisiting. It's very insightful for those that missed the session. So today we are going to be taking another deviative dive. We are not going to be talking about normal Java, normal Spring Boot. We are going to be talking about the fundamental with which every of these things that we've been talking about so far rides upon, which is internet. And yeah, we're going to be talking about it. For those that do computer science in the undergrad or that are still doing it, one of the most complicated courses, network, the internet, you numbers and labels starts flying up and down. But today we'll be looking at the foundations, and some very key knowledge. Okay. So without further ado, um, our speaker is one of my favorites, Fortune, and uh, the last time we took a session, we really enjoyed that session. It was very impactful and knowledgeable. So he's going to be taking us on another session and show you just ready your notes. If you are not with your notes, ready your phone. If you are not with your phone, ready your mind. Right. Okay. Fortune, you have the floor.
Good evening, everyone. So, hope you guys are having a great day. Welcome to today's lightning session. Well, let me share my screen. Let's get on it. So, we're going to be taking a little bit of dive through memory lane to know how we got here. So, one of the things that is giving most of us our jobs, one of the things that we're even using to have these meetings today. So, sometimes it's good to see how we got to this point. Can everyone confirm you can see my screen? We can continue.
Yes, we can see your screen.
So today's session topic, the internet from 4 computers to 5.5 billion people. Eventually, as we're going through the session, we're going to see why the topic of today's lightning session, why is this, and what we mean by 4 computers to 5 billion people. So let's get on it. The internet from 4.4 computers to 5.5 billion people. So I just want us to imagine for a second, because I think in this our modern age, we might take our internet a little bit for granted without seeing all the infrastructure, all the work put into it. So let's imagine for a second that the internet disappears. You don't have any Google, no WhatsApp, no Google Meet, no way to see your friends online, no Google Maps, nothing. So people before 1970 or 1971 didn't have the internet. At least even took a while before it started becoming mainstream here for us in Nigeria. So going from the internet, so just a quick history. Internet started with 4 computers in a university lab, and now it has gotten into the hands of 5 billion people, or at least every single person even if you're not using the internet. 3 years old are on YouTube, 4 years old are on YouTube. So we are going to watch how something that started as a rivalry between two nations turned into an amazing technology that we have today. So could you live without the internet? Can you stay without internet for a month, for a week, for a day, for an hour? I would say that at this point in time, this modern age, the internet is basically like the air that we breathe. Most of us can't go a week without checking our phones. And even if you don't go on the internet, maybe um, there are some issues with your device, or there has to be an excuse on why you're not on the internet. And if you're not on the internet, you feel like you are missing out, or you feel like you're not connected to the rest of the world. So most of us can't. But most of our grandparents were born during an era that didn't have any internet. Anytime they wanted to do something, you had to go to the library, you had to ask around. I know that my dad, when he was in school back then, he used to tell me stories of when, if he wants to check his results, he has to go all the way to his department, he has to travel from BC to his school naked to check some results. He has to, so there are a lot of problems that they faced back then that the internet solved for us. So if you wanted to talk to someone, you call them on their phone, or you call their home phone, and you hope that they answer. You can't just leave a message or leave a DM, like how Samuel could just DM me and the message you get to me later when I'm back online. So things are different. So this thing sounds like ancient history, but actually it was just like 60, 50 years ago that the internet, before the internet actually became mainstream. So what's the internet? The internet is just simply billions of computers connected together. Many people might think the internet is, I want to be on the internet. People might think the internet is Google, is their Wi-Fi, is Facebook, but those are not actually the internet. The internet is, it's the network of networks, something that can connect all devices across the globe. So if if every single device was to be shut down tomorrow, and the devices remaining were us here in this Google Meet, if our computers or the computers connected to this Meet are the last remaining devices in the world, automatically this is the internet. The current computers, right? The largest network in the world, that is the internet. The largest network in the world connecting everyone together, that's the internet. So if there are two computers remaining in the world, and those two computers have an internet cable connected to both of them, that is the internet. So it's a little bit more simple. Just think of it as strings connecting different computers or different cans, all connected to each other, talking to each other, from large data centers that Google, Meta, Amazon owns to the small device in your pocket. Yes, you are part of the internet. So so what happens when you visit Google? So this is an example because Google is really one of the first things that we meet when you want to access the internet, when you want to search the internet. So first it goes from you, it goes to your Wi-Fi, it goes to your internet service provider, MTN, Glo, Airtel, wherever you use. Then it goes to the internet, which here would be the infrastructure. So there are a lot of massive web, where there are a massive web of cables that are just under the sea across the world. So it goes through continents, it goes through countries until it reaches maybe a Google server farm somewhere, right? And then that server takes your request, processes it, gives you a response, and it goes back to you get a page on your browser. But all this time it took for me to explain this, how we visit Google, is 10 times slow than when you actually fetch a web page. Like by the time I'm done with this slide, you have loaded like 10 pages. This is something that we take for granted, but it's actually amazing. It's actually magic. It's actually magical. So before the internet, before we look into how the internet was created, its purposes, or understanding how it all started, we have to look before, because every solution came to solve a problem. So people, before the internet, communication was very slow. People were using letters, newspaper, it was slow, expensive, local. If you wanted to send a message across country, You will have to write a letter, postman, it could post office, it could get lost, it took days. If you wanted to reach out to many people, like if you wanted for a job interview, you have to put an ad in a newspaper. Most of us don't read newspapers nowadays. Most of us don't even listen to the news that much. That's because on your social media, news actually travels faster on social media than it would on any news station. So by radios and televisions actually existed back then, right? But the issue with radio and television is that they couldn't communicate back to you. So if you wanted to actually know what was happening, you actually have to tune in at the right time, maybe 6 o'clock news, or uh, you have to tune in at a particular time to be able to get that information that's actually required from you, that actually require. So it was actually very, very slow. And phone calls were even expensive. So I don't know if some of us can remember when we used to use uh, SMS or button phones where you had to send SMS with 4 naira. Yes, and you had to pack almost all the messages you want to send inside that SMS, because if you don't, just an ordinary high will cost you like 4 naira. And then if you send, so you have to pack all you needed into one SMS so that you can get the most out of it. But then if you wanted to call, like I have an aunt in the US. If I wanted to call her with my normal phone call without WhatsApp or any kind of social media means that we have now, it will actually cost me a lot. International phone calls cost a lot on GSM. It actually does. Text message, international SMS also cost a lot. So keeping in touch with people over long distances was very, very difficult. So the world actually felt very big. It felt uh, very difficult to connect to someone that is far away, because information moved at the speed of paper than of now that is moving at the speed of light, or at least close to the speed of light. So why was the internet created? So here is where it gets dramatic. I think 1956 or 1957, the Soviet Union launched a satellite into space. So normally the US, being a world power now, sees this as a threat, because, well, if a country can launch something into space, it means that they have the ability to build a bomb. And so the Cold War is just economic and geopolitical rivalry between the US and the Soviet Union. There's Russia, Ukraine, and I think Bulgaria. There are some countries in the USSR. So they were always, it's like how we have the AI race today, where we have America, China struggling, everybody struggling to bring out the best models, but a little bit more toxic. So they realized that, oh, wait, they realized that if they can put a satellite into space, well, they could actually bomb the White House. That time, they is very suspicious and paranoid. But the US military realized something, that, oh, if our enemy wanted to get at us, how would they do that? They'll get that through our communication. And telephone lines connected. So how telephone lines work back then is just, let me say, just like our cables. It will pass through, normally, where all of us have transformers. If your transformers spoils or blows, it might take a while for that entire block or that entire neighborhood to get light again. So there was actually a single point of failure when it came to communication. So phone lines led. So if you cut off the phone line of a country, of a city, you have effectively cut out communication from them and from other cities that are connected through them too. So the US had to, they were like, how are we going to go ahead of this? So a general called Paul Barron had an idea, which, well, his idea is, if, well, we have network centers, like they had telephone centers, right, that will plug in your line where it's supposed to go to. What if you remove the centers entirely? This was just an idea, but it was the idea that we have for what we call distributed networks, where even if a network fails, right, the network can still go on. And that is why the internet is basically unkillable. So these are basically just three network types. I just want to show, so we get what I'm talking about. Centralized, decentralized, distributed. Centralized has, obviously, you have a single computer. If that one goes down, none of the nodes can communicate. Decentralized, on the other hand, can help failure, but decentralized technology is more difficult to build and is more tailored on privacy than probably on failure. But distributed networks are the ones that are actually built to handle failures. So our internet is actually distributed. So it's actually distributed. So let's see where it all started from. So AppNet, which is like I think agency research project, it was in 1962. So there were these universities in the US where they had computers. So computers were actually very hard to come by at that time. So it was mainly used for research. The computers that they had then, right? At these universities, we are going to see those universities. So it was just these computers that would fill a entire room. First generation computers, second generation computers, ENIAC, NVIAC, computers that your phone probably has 1,000 times more power than. That was what they were using for research back then. And now they wanted to find a way to be able to communicate between this. So this was actually finding a way for a network. This is not actually the internet, but this is the beginning of the internet. So first four the first four computers were located at UCLA, Stanford Research Institute, UC Santa Barbara. So some of us might be familiar with some of these institutes, some of us might not be, but these were where they are. And some of them were located like 500 kilometers. So communicating with someone 500 kilometers away through a computer is actually something that was quite magical for them at the time. Unlike us that you could message someone in Japan, so this was actually a very great start for them. And these were not just university chosen. I think UCLA was good at networking, Stanford was good at computer sciences, Santa Barbara had a lot of graphic and visualization. University of Utah did a lot of math. So they were actually one of the forefront universities at pushing computing innovation and all that. So they were actually entrusted with building a network that were able to communicate with each other. So this was the first internet message to be sent. So in October 29th, 1969, so I had to research for these dates for this session. I'm not a historian, but October 29th, 1969, UCLA wanted to send a message to Stanford. So they wanted to try. And Stanford and UCLA are like 500 kilometers away. So the plan was to log in. Obviously, we're not trying, it's not an actual login like we have today, but it was to send login. So they sent LO and they sent a G. As soon as they sent a G, the entire network just crashed. Unlike us today that you are sending your images, you are sending your videos. So this was actually one of the first internet bugs. They sent LO, and before the entire login could be sent, everything crashed. So I think after an hour, they got it working. So remember that LOL that I always type in, it was just a character away. That was where these people were from having their one of the greatest bugs in history. But they debugged and they fixed it, and yes, they were able to completely send that login later that day. So packet switching. So this is one of the things that makes our internet fast and makes it very scalable. So it's sure. These are one of the things that make our internet fast and very scalable. Before the internet, if you wanted to send a message, right? Yeah, you wanted to send a message in a letter, you would send everything all at once across one part. But then what happens if your letter, right, couldn't get there, or it was damaged, or something happened to it? If the postman taking it, obviously something happens to the postman along the way. It means that your message, your part is broken, it's broken forever, right? Your message will never arrive. So how does packet switching change everything? So for the internet to work, we have to cut your messages into packets and then send it over a network. And this packet knows how to find their way to the destination. Obviously, there are a lot of networking infrastructure that know how to route the packet where they should be. But if a path to a destination is broken, the packets can eventually reroute themselves through another path to get to us. So that is why the internet is very, very strong. It can't just crash, because even if a route is down, right, it will find its way. Or unless there is no way to get there, then you have like a network failure. And this is not the internet still works. It's just a part of it that is down. And eventually, once it gets to the right place, everything is reassembled. So as we can see, and this is just a small example, hello, but we are sending two characters along, and all of them would travel. This one could follow route A, this one could follow route B. As long as they get to the same destination, the destination eventually will join all these, regardless of how they come, and then join it back to this hello that is here. So why it changed everything? Uh, So we know how Google Maps will reroute you when you have traffic now. That's exactly what packet switching is all about. If you have like if you have a part on internet that is too congested, there is too much traffic, it's broken. Packets just automatically find their way around it and find their fastest way to their destination. That is what makes the internet almost unkillable. So even though there are wars, earthquakes, tsunamis, as long as there is a path that connects to you, your packet will get there. So even if parts of the internet can go down, the rest can still be up, which was what the internet was intended for. So there's no single switch. There's nobody that can just flip a switch and end the internet across the entire world. The only way to end the internet across the entire world is to stop everything at once, which is how the internet was designed. It can't come down unless you bring it all down. So we're going to talk about one of the things that makes what we are the internet more structured, because I know the internet is just a network. It's not usable unless you have a protocol, unless all these computers that are using it actually agree to something. So back then in the early days, things were different. There were different networks that were set to different chassis or different languages, right? So it means that on a French network, the characters they will use there, or the way a French network will send messages to French computers will not be the same way that US ones will do it. And even in the US, even if a computer could send to another one, a, a US computer in the military might not be able to send to one in the lab, because they were all configured separately. So this was their best choice, using TCP. So TCP just became like the universal language for the internet, where all computers have to follow these rules, making each packet. So IP, right, that is Protocol, handles routing packets to their destination and finding the best paths. It handles addressing, uh, giving each computer its own unique address on the network. And then TCP has to do with the protocol that has to chop your data into packets and put them back together and reassemble them at their destination. So this is actually the glue that holds the internet together. So the internet's birthday. So why will I say the internet's birthday? As we saw, it was in 1969 that the AppNet actually started. But is that really when the internet started? Like I said, the internet is when computers can communicate to each other. So it means that if the network in the US and network in Japan and network in China all can communicate to each other, it means that that is not the internet. So every ARPANET machine switched to TCP IP. That was what changed everything. Now everyone could actually communicate to each other. Everyone had a coordinated protocol to be able to communicate with each other. And to do this, all of them actually had to switch. All the computers, all the machines that decided to use the TCP IP actually had to switch at January 1st, 1983. So every January 1st, that was actually technically when the internet was born. So now, because of this TCP IP, a computer in London can communicate to one in Brazil, can communicate to one in Nigeria. So that was it. So DNS, another important feature. So I have not as occupied. I found I can see my network have issue.
Oh,
Yeah, your network went off earlier.
yeah. I thought it was my side.
Me
Oh,
too, I was thinking it was my own network as well.
hello,
Uh,
is your network okay now? Fortune. Okay, guys. Let's give him a minute to come back. I thought it was my network. Alright, guys. For those just joining, we're having a bit of a network issue, so our speaker will be joining soon. Okay, apologies, guys. I think his network is very bad. I think this one is really affecting the network. Oh, let's give him 2 minutes.
I'm sorry, everyone. It seems like my own internet is beginning to fail. So, can you confirm they can see my screen? Let's continue.
Yeah, I can see your screen now.
So I don't know where was I lost? Where did I? Yes, can you confirm where last you saw my screen? Which slide?
Uh,
Did you see all this?
White packet. Yeah, when you started talking about the packets, I think the voice disappeared around that packet switching.
No, we are way past this place.
Yeah, we got to DNS, right?
Yes, we did.
Okay. So I think I was trying to show an example of my IP address. That's what I was trying to do back then. I think my not jinx it. Can you guys see me?
Yes, we can hear you.
So let me just continue. Sorry for the delay. So this is a problem that people don't really think about. Every device on the internet has an address, which is just a number or bytes. For some of us that have done a little bit of development, you could see IP addresses when you are doing your local host 127.0.0.1, or when you are connecting to a mobile hotspot through some kind of, I don't know what development to be into, but in games, even in games too, where you have to type in your 192.168 and your IP address. So so every time you visit a website, the computer has to look up a number. So imagine trying to memorize a site. This is another problem that the internet had that DNS came in to fix. So we cannot be memorizing the IP address of Google and every single site. So we need something that is a little bit more human readable. And that is where DNS came in. So before your browser connects to the internet, or at least fetches data from the internet, it first resolves the nomenclature that it gives it into a string of numbers, which is actually what is going to be used on the internet. So it's just the internet's phone book. So you type in google.com, your DNS, your browser goes to the DNS server, it finds the IP address, then eventually connects to Google server. So you guys can see my screen, right?
Yes, we can.
So this is just a little bit demo. So if you type in the command ping google.com, you will notice that we are getting data from 192.178.24.142, which is probably an IP that belongs to Google. And we see how long that takes. That takes almost like 200 milliseconds. That is, this server we're communicating with could be in South Africa if they have something there. It could be in US. It could be in California. I don't have passport to leave Nigeria, but my data did. This is almost 200 ms. That is actually very, very fast. That's actually very, very fast. So 6 packets transmitted, 6 packets received. So these two, ping google.com, just helps us to see whether we can communicate or whether we can reach out to a website. So another command that I would like to show would be that is ns lookup. So I actually use this a lot. If I set a domain and I want to check if the domain matches the IP address I set, either on Namecheap or a domain provider. So sometimes it takes a while for your domain to come up. So if you want to check if your domain is up, or you want to check a particular domain, the data associated with the IP associated with it, you could use NS lookup. It will show you the domain server you use to resolve this google.com, and eventually it shows you the address of google.com. So if I was to take this address, right? Okay, yeah, as you can see, my browser still took that IP address and resolved it to something more human readable, but it took us to google.com. So Google actually might have many IPs associated with them, but the one I was able to reach out to, the one I was able to hit was this. So there's another command saying trace route. So trace route is this will probably be more for cyber guys that want to do more. So this is this command just shows you how many hops your packets went through. So we get to see the servers that our packet went through. We went to this server that had this, went here, went this, went there. 22 milliseconds, 42 milliseconds, how much time is spent on each server before eventually it will get to Google. So this will just give us info of where this 64 hops mark. So it just give us info of how our data traveled or how our packet traveled before it got to, that is 142.12. That is this IP address that is here. Or maybe one of them belongs to Google. So how it went around the world and eventually came back to us. This will just help you to trace it. Let's just keep going. So the internet versus the World Wide Web. So forgive me for my verses, but they're not really in any competition. We have to understand that there's actually a confusion. People would think that the internet and the web are actually the same thing. They are not. The internet is just the infrastructure that builds the network of networks. The cables, the routers, the protocols, all the physical things or the physical stuff. The World Wide Web is just a service, right, that runs on the internet. There are other services that run on the internet, like the emails, like our emails. Emails do not run on the World Wide Web. They use the internet too, but they are just a service on the internet, just as the web. So you can have the internet can actually run without the web, but the web cannot run without the internet. But I would say in this modern day and age, the web is actually what makes the internet more useful to me and you, people who are not at UCLA or people who are not at those universities that use them as for research. The World Wide Web is the way through which I would say a common person like me and you can be able to access the internet and actually find it very, very useful. So this is just an example: the infrastructure, the hardware, the roads. Why the World Wide Web are the cars on the road. A road can exist without the cars, right? But what use are roads is building a road if there are not going to be cars or people that are going to use it? So the World Wide Web is one of those services that make the internet interesting or make its usefulness to come out. So we can't really talk about the World Wide Web without talking about Tim Berners-Lee. Yes, the man did not create the internet; he just created the web. So in the mid-90s, right, in around 1980s or 1989, so the man is a British physicist. He was working at CERN, so they do a lot of particle physics and all that. So a lot of these things were actually people that were into physics, maths, computer science. So different people around the world, right, were sending data everywhere, and it was looking messy. So I know all of us, some of us might be familiar with Web 1, Web 2, Web 3. Web 1 was just plain static. Web 2 was one way you could interact back, and we have our Web 3 that is more decentralized. So if you thought web, the actual original web where you have like a default web page that makes your eye wants to make you want to gouge your eyes out, remember that there was a time when they couldn't even have a web page, where they couldn't have structure. It means that you just see, you open your browser and you see just plain text. Or it's not even a browser, they were probably using a shell or a terminal, or whatever screen they had back then. So Tim Berners-Lee, this came as an issue and he had to fix it. So he invented a system, just like every great engineer. He solved his own problem, and it became a problem that he could share with other people too. So he invented a system, a way to share documents, right, for his fellow scientists, called HTML. That is hypertext markup language. And then HTTP, that is a protocol that is also built on TCP. But the server and client, the client requests a page or a document from the server, and then the server sends that document back and tells the client that, oh, I'm done. And then everybody closes their connection. Very simple protocol, but it's what builds our internet. URL, the path or the address to get the documents you need to, and then a browser, which is the actual program he wrote. So I don't really know. I think the first browser would technically not look like what we have today. It would have been a very, very simple program with you put in an input URL and then maybe to display HTML using HTTP. After you have used HTTP to get the HTML file, it will then display it for you. So he called it the World Wide Web. The interesting thing about it is that Tim Berners-Lee did not patent this technology. Yeah, I would say that the internet is worth more than Elon Musk's network. Is worth more than Elon Musk's network, right? And is if he wanted to be a trillionaire, he could have actually done it. If he decided to hoard this protocol, because this is what is used, almost every single thing we're using nowadays is based on this. He didn't. He let it out. I would say this man gave us one of the greatest gifts we have had, which is the internet. So I would just like us to remember his name, Tim Berners-Lee. We're going to talk about search engines. So we know that the web actually grew fast. So I would say in the 90s, there were like 1 million pages, right? But how do you find anything? We have talked about IPs and how DNS solved it, but this doesn't really solve any issue if it was very difficult to find that page you intended to. So we have early search, there were early search engines like before Google, Alta Vista, Yahoo, then Jeeves, Ask Jeeves. But the problem with all these search engines is that imagine you are searching for a car. You could get carrot because car and carrot were almost similar. Because the three letters starting carrot was actually car. So their search engines, right? So their search engines, right, could actually approximate those things together. Confirm, can you guys hear me? Okay.
Yes. Okay.
So, oh my, this generator. So then Google arrived. What made Google special? So Google found out that, well, instead of the common approach that we are normally using for search engines, where you search based on keywords, we are meant to rank pages by how other pages are linked to them. So based on this, Google's search engine was able to perform better, and Google is basically what we use now throughout. It's actually dominated the web when it comes to search engine. But Google is just like every other website. It's not the internet, but I would say, is a window. It has made itself a window into how most of us browse the internet. It didn't just become a billion-dollar company. It became a verb. I want to Google this, I want to Google that. And it was started by Larry Page and Sergey Brin, which are just two Stanford students in 1999, 1998. That's when Google started. And they built a solution to solve the previous problem of search engines. So as we are seeing the history of the internet, it's beginning to unfold that people come up with solutions to solve pre-existing problems. So the rise of social media. So for its first 20 years, the internet was just information. You had to go online to read, to research, to find things. You had to Google. But then social media kind of changed everything. Facebook turned it into a place where you could connect with friends. Twitter made it into a place where you could share your human thoughts, whether they are reasonable thoughts or whether they are not even reasonable. I don't have an issue with X. So. Instagram made everybody a photographer. You could post your lifestyle, you could post anything. So it changed the web from just being TikTok was for short form video revolution, content creation, and the rest. It changed the whole scope of the internet than something that you go on to read to something that you actually actively participate in. So that's how we see it. So social media gave us that ability to be able to take this internet, this amazing technology, and actually participate in it. Instead of being just the consumers, we actually create too, right? And we can share, and everybody can participate, and everybody can be a publisher on the internet. So another thing that changed throughout the history of the internet was smartphones. So before all this happened, before they started using smartphones and the rest, if you wanted to use the internet, you actually have to go to like maybe a cyber cafe and pay for the internet. It was actually very, very stressful. to browse until we started getting mobile devices. So before, internet lived on computers. You had to go to where a computer would be, maybe pay some amount of money, or if you are rich back then, maybe you could have the internet, I think. But now everybody carries an internet on their devices. Before, you had to sit at a desk, open a computer, log in. Today, and the internet is not just a place you go to. It's something you carry in the pocket, something that you sit down in your living room with your phone and you access. An average person checks their phone almost 100 times a day or 50 just browsing the internet. So internet went from just being a destination to being the air that we breathe. And we probably don't even notice it anymore. So cloud computing. So you no longer store everything locally. So we have Azure, AWS, Google Cloud, which power most of our websites today. But remember when we had to save everything on our hard drives, we have to transfer to people. Today we have iCloud, we have Google Drive, we have Spotify, we have Netflix. But remember, the cloud is just a service too over the internet, a service built on top of the internet. So the cloud is not some kind of cloud in the air. It's just someone else's computer somewhere that is much more stronger, much more efficient, much more powerful. That's able to handle it, but then render services to you through that same internet. So every time you have a picture and you upload it to Google Meet, to Google Drive, remember that you're actually still using the internet. You're still using a service on top of the internet. As we are going into this AI era, there is no way the AI would have been able to reach us if we didn't have the internet. There is no way if you wanted to run a model, you probably need some kind of high tech end tech, which most of us we won't have. And even if you had, it means you have to run a local LLM and everything. But today AI runs on the internet. As much as we are amazed by our ChatGPT or Claude or Gemini, remember that it's the internet that holds all this up. Without the internet, most of these models that we use or LLMs won't have been able to communicate with us, won't have been able to see them at all. It will have just been a research thing in a lab, something locked in a lab. But with internet, those AI research actually reach billions of people. And I can talk to a brain living in a server in California, in Texas, or in China, maybe in Lagos. I don't know if we have anyone here. So that is only possible because of the internet. So the internet today, yes, here are the numbers. There are I think there are almost 8 billion. So I think there are still people that don't have internet access, right? But I can say that half the human population have it. 70% of the human race are actively using the internet. The website is being viewed every day. Hundreds of millions are up. Searches daily are billions. Messages are billions. Data transferred, thousands of petabytes daily. From the word LO to now sending LOL, OMG, sending all your memes and everything. That is what we have today. So that's the story of the internet. From LO that crashed the network to sending videos, having conference calls, having meetings like this. That is where we have gotten to today. So what's next? What's next for the future of AI? For the future of the internet? So the future, right? As much as AI agents don't answer some questions, they do things for you. That's what the internet is going to move into. As we see that our AI agents won't just be communicating back to us through the internet. We're able to do some things for us. Satellite internet, something that we're seeing is getting more traction through Starlink and the rest. It's getting to places that our normal telecommunication towers might not be able to reach, or infrastructure might not reach. Smart cities, the only way you can have this is with embedded devices that will obviously talk over the internet. Self-driving cars, quantum networking. So these are actually some things that are projected to change in the future or get better in the future because of the internet. Remember that AI cannot be built it wasn't built without the data gotten from the internet. I think that is what OpenAI actually used to build their model. They had to take the entire data on the internet to feed and train their model. So without that technology created in 1989, we wouldn't have actually gotten to this stage So everything is actually connected and everything is actually built together. So it's worth noting that the internet is actually still very young. We have older technologies than the internet. The internet is almost like 55 years old or 60 years old. So it's actually still coming and things are still evolving and things are still changing. Our networks is getting faster. We were in 3G before, we're in 4G, there's probably 5G. Is there 5? I think there's 5G. Yes, there's 5G. So things are always going to get faster, things are always going to get better, things are going to move a lot. People are going to move a lot. So by 2050, a lot could actually change. All these things I spoke here could actually change. And the internet could just be, who knows, you could be downloading 2 gig per second. Or there are currently people who are probably even downloading like that. So let's try to debunk some internet myths. As we see, the Wi-Fi is not an internet. Your web is not the internet. Google is not the internet. Your Wi-Fi is just a connection to the internet. So instead of connecting via a cable or a physical medium, it's wireless. The web is not the internet. It's just a service on the internet, just like your email. Google is not the internet. It's just one of millions of websites. It's no different from a website that you built. It's just that its work under the hood is to index other websites too. So, and it's a window to the internet. All these are very important. Without the Wi-Fi, you might not be able to access the internet. Some of us might be connected to the internet now via Wi-Fi. Obviously, all of us are using the web right now for this meeting. Some of us are using Google Meet. So, even as much as there are bedrocks or there are, let me say, layers that we interact with a lot, remember that the internet can exist without them. So let's just go through some of the fun facts so I watched a YouTube video on one of the first webcam videos actually streamed. It was just the University of Cambridge. They actually just put a coffee cup with a webcam, which is just, I think, a camera that was taking pictures every second. So, and people actually tuned in to watch because that was actually the beginning to video conferencing. Before, what you could see was images on the website. You couldn't really see video. So the first webcam watched a coffee pot. People actually tuned in to watch a coffee cup, and from there things changed. The first message sent was LO, and 99% of internet traffic actually routes through undersea fiber optic cable, not satellites. So as much as you might think that the internet is flying in the air, remember that for it to cross continents, it actually goes through undersea cables. A lot of it actually goes through undersea cables. An email travels the world in seconds. So as we even saw from our opinion, 200 milliseconds, your data has actually gone all the way to a different continent and back. That is how fast. I think fiber optic should be able to transfer as 1/10 the speed of light. So it's actually very, very, very fast. So, okay, before we come to this, I would actually love to hear your thoughts on any questions about the internet. And we could actually learn more about this session, but because of time, let me just. So the internet didn't become powerful because it connected computers. It became powerful because it connected people. Today, because of the internet, a lot of us are software engineers. We build on the web. It gave most of us our job, our purpose, our career. A lot of people that have businesses, a lot of young people that have businesses this generation, that a lot of people that have businesses always use the internet. Your social media, your Instagram, whatever startup you have, if you want to go global, you can't go global without the internet. Every single business is pivoting into a way with the internet, which is in the internet. Our mobile banking, our communication at work, in school, everywhere, your research work, every single person is using the internet. And I do get there are a few people who do not have access to the internet, right? But I would say that they are missing out a lot. Yes, the internet can have its disadvantages, but I would say that at the end of the day, it's the bad people who use the internet to do bad things, right? The internet is a technology meant to connect us all. And that is why it's very, very powerful, because it turns all of us into a global village. It turns the whole world into a global village. So I can be here and communicate with someone in America, someone in Europe, someone in Japan. All of us watch the World Cup Before, if you wanted to watch the World Cup, you probably had to listen to it through a radio or through antennas. You had to wait to a certain time, which was very, very stressful. A lot of us streamed the World Cup, felt connected, felt emotions, felt this. And as much as we are seeing Messi play ball, Argentina and Spain and the rest, remember that without that internet, you might not be able to watch these people. Without the internet, you won't be able to stream Burna Boy's song. Without the internet, you won't be able to pay for whatever food you paid for probably this night. So that is where we are. And yes, my name is Shiromi Ikechukwu Fortune. It's just my profile. So I do Java, Spring Boot, NAIJA-JUG community. And thank you very much for being with me throughout the session. I'm very sorry for the network issue. So I think at this point we'll move on to questions. So thank you. I would love to hear your thoughts. So any question about any history you want to, any kind of addition anyone wants to make, what you think, let's just talk. So any questions, anyone?
Okay. Thank you very much, Fortune. I really appreciate. We really appreciate the insights. I mean, this is actually a very high level fundamentals. Again, that's even if you're not a computer science student, it's something that you should know, and it pricks your interest as to want to know more. Thank you very much. We really appreciate. And for those just joining, the link to our communities on the chat. You get it. The chats. We do this weekly. We um, throw insights into these things. So thank you very much. So personally, I have a question, and I know Oluwatimileni has a question. That's why he has been raising his hand since. So before I ask my question, Oluwatimileni, please go. You are laughing. Okay, that's fine. No question. Who else? Who else has a question? Okay, let me ask my question. My question is coming from the statement you made about getting faster and it keeps getting better. So, uh, although I know Nigeria is mostly otherwise, you get in
Yes.
this, Nigeria is mostly otherwise because we can say that the Western or Igbo people, as I'll say it, they are they have their internet, they have those things that we are begging MTN and Glo for. It is they already have very stable, good internet. You get that we are paying so much, and you can just enter a bus and get free Wi-Fi. So how does the growth of this network, how does it, probably in your own POV, I think, how does it affect Nigeria? I'm sorry I'm bringing Nigeria into this discourse. Although, yes, it moves forward, but I feel like the moving forward won't really do us much good because we are in Nigeria. It doesn't, it's the profitability of something that even even pricks curiosity for advancement. Yeah. So how does it profit Nigeria in any way?
So let me understand. You're asking that you don't think we'll get much advancement because of how we are, right?
Yeah. I believe because I heard of the truth behind MTN 5G. That is actually not really 5G. It's not because after they've made their announcement for 5G, that was when officially, I think it was a couple of months later, officially that 5G was actually out. And MTN now has already been lying to us that there's a 5G, that they have 5G. You get what I'm saying? So
Okay.
you get all the things.
So concerning that 5G one, I think I read a little bit about it. Um, I think what currently what our service providers are doing I don't think we have true 5G. I think we're using 5G, right? But through our 4G infrastructure. That is the way that they do it. So I won't say that I'm a professional on network infrastructure. But I would say that yes, compared to the rest of the world, our network, like we saw, I had network issues here on the call. All our sessions when we are using it, Josh or um, with some of our presenters from abroad, right? But normally, if there was a network issue, I know it's from me. I know it's not from them. That is wow. That is how it is. So I would say that yes, we could get better. We could get better because as we see, people are opting to Starlink because I would say some of these things sometimes is based on the part of the government or the people running the business or the monopoly that is happening in the network space. As we can see, Starlink came in and a lot of people are actually using it. A lot of people are actually going for it because they see the value in it. They see the strength in it. So would this actually affect us? Well, I would say yes, it will actually slow us down a little bit. It wouldn't. Why? Because eventually it wouldn't. Why? Because we have, like I said, Starlink came in. We can see that even as much as we are not at the speed of the entire globe yet, um, MTN we have actually gone from 3G to 4G. Me browsing the internet, I know that me browsing the internet 2016, 2017 is not the same speed I have now. Now I could actually download a movie worth of 200 MB in seconds, and sometimes it still shocks me when there is good network. When there is good network. And some of us actually complain about our data is to finish fast. But we should also remember that um, I used to check my data usage. I used to check my data use very well. I do not know if MTN are doing some kind of notorious things under the hood. But everything usually matches up. Everything usually matches up. It's just that because of I think the inflation we have had, right? Data price before your 1K could last you for 2 days, 3 days. Now your 1K sub is like what few hours, 12 hours. It's not even a full day. Some of us spend almost 1.5 on data every day. So if you use that kind of mentality, every time it will finish, you'll be like, more MTN, what they do, but it's actually the pricing changed, and thus everything has also changed as well. And I would say also our network, the internet actually had more quality now. So it's not like back then that your images were like 500 KB, 1 MB. Images now, if someone snap a really good iPhone image, it's going to be 12 MB. So if you use that your 1K sub and sub something small like 500 MB, and you enter WhatsApp and enter a group chat, and people drop their stickers and drop their images, your data is going to finish. But there's something I noticed about our internet providers. They actually have a lot of things to do when it comes to network speed. Our network speed or our network is not that stable. It sometimes disconnects. Like my SIM actually showed an X. That is why my internet went out. I didn't have service at all. It's not that I didn't have less service. I didn't have service at all, which is we're in the 21st century. These things should change. But like I said, Starlink has come in, and maybe that should be what some of us who, if you feel like our current service providers are not good enough, I would say to opt for that option, right? It will really be good. I know somewhere. I don't know if I covered part of your question. Okay, I won't.
Yeah, yeah. Yeah, I think you answered properly, and I think my take would be that while it is the network and the internet of things, the internet, sorry, is getting better. The primary reasons why Nigeria is probably behind is cost. Like it's good, it's moving forward, and then but the cost is just the cost for individual, like per person,
Yes,
is
exactly.
too high. But like the Starlink you mentioned, Starlink is here, but it's crazy expensive. In
Very
fact,
expensive. Yes.
As even average, you still cannot maintain static. You get, but yeah, I get. Oluwatimileyin, you have a question?
Yeah, good evening, everyone. Nice presentation. Ikechukwu, like very great. And yeah, I wanted to react to Sammy's question, right? And I think beyond the question and answer, like it's even worth it it's worth a teapot session, or how they call it. The way you see, then I actually analyze this kind of thing because this is more than just a question and answer. And I think this, if you look at it in holistically, it's not just if you decide to say, hey, what is the gain of, what will be the gain of Nigeria, if this network is good and something like that, that kind of stuff. And let's even remove the problem of, hey, why is it like this? Let's even look at what's the gain if the network is actually very good. Thinking of it, I think it's in itself, it would be both if an infrastructural and a catalytic good. What I mean is, when the internet is just good, for example, say you're in a village, for instance, or a town in Nigeria, you don't have good lights, you're always cautious of, you're always owning your charger. When you're going to your friends, you're always owning your cord, that kind of stuff. Then you move to, say, Lagos, and you are, you're not used to the system. You just found out that maybe 17 hours or so, maybe for this, where I am, for example, there is light. You start becoming more relaxed mentally, start dropping that charger and wanting to charge every now and then. Just feel like there will be light. And from there, you can think of things of, the kind of business you would think of when you are in your village.
Your productivity
will not even be dependent on charge, light, electricity, right?
Yes.
But when you come here, you start just thinking of things that you wouldn't say, oh, it's because there is electricity that I'm thinking of this. You would just see it natural that you should actually think of this and do this. Just like how the whites and abroad, they would just feel like I should do this is supposed to be possible. Simply because the infrastructure, the underlying infrastructure are just there, right? So ideas and all these infrastructures will be built on things that already existed. So same as the internet one. When you think about something, when I give you a pen and paper, and I say benefit of electricity, start 2 minutes. You start like, it's a cure poverty. How will it cure poverty? How will it cure cancer? You start thinking one and all. But like when you calm down, settle down, and you really discuss something like this, you find out that it actually powers a whole lot of things. Companies that run Internet of Things, IoT things, we now say that, oh, my internet is actually better. So information and all this old stuff. You will start building better security stuff on the internet because internet is already good, but now securing it is the next problem. His next challenge. So innovations will come. So it is a catalyst to greater things. So we can actually undermine the benefits, right? We can actually undermine the benefit. Yeah, just sharing your thoughts on it.
Yeah,
that's it. Thank you.
I actually resonate with you very well because a lot of us here might be developers, right? Java developers. And a lot of us had to burn our fair share of candles and data just to acquire the skills that we have. So if you have any online skill you want to have, you actually experience this. If you're a student, in fact, if you're a student in all professions, medical, right, medical engineering, and you really need to do some research, or the internet is very crucial for you because you can't think about what you probably don't know. So I would say that internet will expose you to a lot more. Your productivity will go up. Your boundaries will be opened, right? You will not have too much bounds. You think more at a higher level, because once you go to the internet and you see some things, because I can go on the internet now, I will see a GPU and I'll be like, I want this. If I didn't see that, my mind, I won't even know that something like that even exists. You get? So I would say yes. The internet, I think internet access is something that, like I said, is kind of the air that we breathe in this modern, as young people in this modern age. The internet is heavily integrated into our lives. Thank you, Aroni.
Thank you very much, Fortune. I thought I saw somebody raise their hands. Okay. Okay.
Imadi, right? Peter Imadi. I think you want to say something. Right.
Okay. Okay, Imadi, yeah, you can go ahead. Let's wrap up in the next 4 minutes. So just go ahead so we can wrap up. Imadi.
Hello, am I audible?
Your
Hello,
volume is
am I
low.
audible?
Yeah. Good, good.
Okay. So first of all, I'd like to appreciate the organizers for setting up this session. So my question is not really a question, just a clarification. And you mentioned when you were describing how the internet works, you mentioned the internet service provider and how it's part of the process, and how the internet works, and how we send requests and receive resources over the internet. And I would like to ask, what specific role does the ISP play?
Okay. What specific role does the ISP play? So, like I said, the internet is actually a network of networks. So, the cables that connect the continents together, you can see them as their own network too. But me and you, right, who have no access to those cables, or who don't have access to those infrastructure, we can't access it. Just being an individual sometimes is not enough. So the ISPs, how they come in is they build that infrastructure and they connect, like MTN. I think MTN, and they talk to main one, and there are a few actual internet providers, people that are actually connected to the internet. So MTN, Airtel, Glo, they actually have deals with these people. And then they have SIM cards, right, that they give us, the users, to communicate to their telecommunication towers, which routes in their network. So what you effectively do is you communicate to your ISP's network, and then the ISP's network, right, will forward that's your request into the internet and receive it back for you. So without your ISP, you'll probably not be able to access the internet. You can't access the internet, and that is why you pay for your data plan. So anytime you pay for your data plan, you're effectively paying for accessing the ISP's network into the internet. That is your upload and your download from the internet. That is what you pay for. Do you understand me?
Okay. Thank
So
you very
I
much
just
for
have,
that. I don't know, Imadi,
I just have something
that's
to
okay.
add. So I would say the ISP, why most of our ISP are actually very, very important is because most of the infrastructure we see currently is actually for SMS, for phone calls and telecommunication. So they have already built all this to connect us earlier back in those days. But as the internet started coming in, the ISPs, right, they could actually use this infrastructure for telecommunication to connect to the internet. So that is why I would say that our ISP is actually very dominant, because they took the telephone or the telecommunication infrastructure that they had and plugged it into the internet. So now regular people who are making phone calls, who are sending SMS, oh, now we can access the internet through these same people. So I would just say that I don't know what to call it. I don't know if I should call it pivot, but it's just one of the services they added. Once the internet came on board, they added it as one of their services on top SMS and calls. Peter, I don't know if that was okay.
Wow, that's clear, very clear. Thank you.
Okay. Okay. Thank you very much, Fortune. Our time is we added to 2 minutes, but it's worth it. I mean, it's worth it. The clarification, I mean, though I think I've studied a bit on ISP, but this even grounded the knowledge the more. So I really want to appreciate each and every one of us for joining the session. Notes we Our session goes on like this. We have next week Tuesday, and our monthly session is this Saturday, we'll be hearing from an expert and one of the top contributor of OpenG Proxy. In case you don't know that, that's an open source project. I advise every Java developer to actually contribute to that project because it could be the next big thing. Okay, so he's one of the top contributors, and that will be his first time speaking publicly. So it's I think Robert, I'm forgetting his name, something Pretisha. So yeah, have a nice one. Have a nice one.
Let me take a screenshot of this. Yeah. Thank you.
Bye everyone.